Being able to add and subtract fractions is a crucial skill that you will need on the ACT. In this video, we are going to review adding and subtracting fractions. The most important thing to remember when adding and subtracting fractions is that you must have a common denominator before adding. That makes it a little more complicated than multiplying fractions. With that being said, let's move on to a few examples. First, we have 3/5 plus 2/5. They already have a common denominator of 5, so we can simply add across to get our answer. So that'll give us 5/5, which of course is equal to 1. In our second example, we have 7 over x plus 1 plus x plus 3 over x plus 1. Of course, these also have a common denominator of x plus 1, so again, we can just add across the top, and that'll give us 7 plus x plus 3 over x plus 1. We can simplify the numerator further, and that'll give us 10 plus x over x plus 1. Last, we have a mixed number, 1½ plus 4½. What we can do is we can write these as improper fractions in order to help us add them. So 1½ can be rewritten as 3/2, and 4½ can be written as 9/2. Now we can add these together, and that will give us 12/2, which is equal to 6. Let's move on to a couple more complicated examples where we do not have a common denominator. So in the second row, we have 4/9 plus 11/30. We cannot simply add the numerators because a 9th and a 30th are not equivalent. So we need to find a common denominator. We can get a common denominator by multiplying each fraction by some number that is equivalent to 1. So between 9 and 30, if I wanted to make them common denominators, I would find the least common multiple of 9 and 30. Or I can find any common multiple. It doesn't need to be the least common one, but that just makes it easier at the end. So with 9 and 30, just looking at it, I can guess that the common denominator is going to end up being 90. Because if I multiply 9 by 10, I get 90, and if I multiply 30 by 3, I get 90. So what I'm going to do, I'm going to multiply 4/9 by 10 over 10. Which of course is equivalent to 1. So I'm not fundamentally changing the fraction at all. For 11 over 30, I'm going to multiply that by 3 over 3, which again is equivalent to 1. So when I do that, I get 40 over 90 plus 33 over 90. That is going to equal 73 over 90. Next, we have 7 over x plus 3 plus 6 over x plus 2. In this case, it's a little more abstract because we have denominators that involve variables. However, the same concept still applies. We want to get a common denominator between x plus 3 and x plus 2. So how do we do that? Well, if I multiply the left side by x plus 2 over x plus 2, and if I multiply the right side by x plus 3 over x plus 3, then that will give us a common denominator of x plus 2 times x plus 3. And then we can add across the numerator. So let's do that. So if we multiply 7 times x plus 2, that'll give us 7x plus 14. And now we're going to add 6 times x plus 3. So that'll give us 6x plus 18. And of course, this is all over the common denominator of x plus 2 times x plus 3. Now let's simplify the numerator a little. So 7x plus 6x is 13x, and 14 plus 18 is 32. And we'll put all that over x plus 2 times x plus 3. So far, we've only done addition, so let's do some subtraction. We have 5/6 minus 1/3. Again, we're going to need a common denominator. So between 6 and 3, the common multiple between those is 6. So let's multiply 1/3 by 2 over 2. That will give us 5/6 minus 2/6. Which of course, when we subtract 5 and 2, that gives us 3 over 6, and we can simplify that to 1/2. For our final example, we have x plus 2 over x plus 1 minus 2x plus 3 over x minus 1. Just like in the above example where we had variables in the denominator, we need to find a common denominator. That common denominator is going to be when we multiply the two denominators together. So let's multiply our first fraction by x minus 1 over x minus 1. And we'll multiply our second fraction by x plus 1 over x plus 1. For our first numerator, we're going to apply FOIL to x minus 1 times x plus 2. That's going to give us x squared plus 2x minus x minus 2. And then we're going to subtract our second numerator. So I'm going to put a negative and then parentheses. That way we remember to distribute the negative sign. And then I'll apply FOIL to 2x plus 3 times x plus 1. That gives us 2x squared plus 2x plus 3x plus 3. Now I'm going to distribute that negative sign. So I'm going to change the negative to a positive and apply a negative sign to all of these values in here. And of course, all of this is over our common denominator, x plus 1, x minus 1. So let's simplify this a little further. We're going to get negative x squared minus 4x minus 5. And then all of that, since we have x plus 1 times x minus 1, that's actually equivalent to x squared minus 1. And that is our final answer.